Section 4.2 Interactive Assignment Objective 1. A pediatrician wants to determine the relation that exists between a child's height, x, and head circumference, y. She randomly selects 11 children from her practice, measures their heights and head circumferences, and obtains the accompanying data. We're going to complete parts A through E. In the first part, it says we want to find the least squares regression line, treating height as the explanatory variable and the head circumference as the response variable. So I'm going to go ahead and click on this data. I'm going to go ahead and now open this up. So open this up in the StatCrunch. Okay, so here is our X column and here is our Y column. So what we're going to do is we're going to go to Stat, and then we're going to scroll all the way down to where it says Regression and then select Simple Linear. I'm going to make sure that the X variable is the height, which is the X inches, and the Y variable is the head circumference, which is Y. Okay, and then what I'm going to do is I'm going to scroll all the way down here, and again, what we want to be able to do is we want to find out what is the least squares regression line. So let's select Compute. Okay, and then what I'm going to do is I'm going to go ahead and then copy this information that's in this table. So let's take a look at this here. All right, so again, we want the least squares regression line. So if you notice, it's in the form of y hat, which is equal to the slope times x plus the y-intercept. Okay, so if we take a look at our question here, we can see that the slope down here is in the form of 0.20588235. And it says we need to round this to 4 decimal places. So we're going to round that to 4 decimal places. And so we're going to end up getting y hat, which is equal to 0.2059, and that's x, plus, now we want the y-intercept, and the y-intercept is that value there. And again, we're rounding that to 4 decimal places. So that's going to be plus 11.871 and then 4. Now let's go ahead and put this information into our example here. Okay. So we have 0.2059 x plus the y-intercept, which is 11.8714. Now let's check to make sure it's correct, and there is our answer. Now the next question says, use the regression equation to predict the head circumference of a child who is 25 inches tall. Now to give you sort of a more of a visual of what we're doing here, we're going to put this equation into our calculator, our Desmos calculator. So I'm going to put in 0.2059, and that's going to be x, and then plus, if we go back to our question here, we have 11.8714. So 11.8714. Okay, now there is our graph. This is what our graph looks like. Now, what I want to be able to do is now the question is asking me to use this equation to predict the head circumference of a child who is 25 inches tall. So let's go ahead and do that. So we're going to use this equation here that we found. So I'm going to put that over here. Okay, so here is our equation. All right, so there's step 1. Okay, and now it's saying that we want to let x equal 25. Okay, so in step 2, we're going to let x equal 25. Okay, and then in step 3, we're going to plug it into our formula. So it's going to be 0.2059. We're going to multiply that by x, which is 25. And then we're going to add 11.8714. Okay, so if we do that, and I think I did it on a calculator here, we're going to take 0.2059, multiply that by 25, and then we're going to add 11.8714, okay, which is 17.0189, and we need to round this to 2 decimal places. So rounding it to 2 decimals, first put the answer in, so it's 17.0189. And now we're going to go ahead and then round this to 2 decimal places, which is 17.02. So we're going to put in our answer here, and you're going to see that the predicted value of the head circumference of a child who is 25 inches tall is 17.02. Now let's just go ahead and put that ordered pair into our graph. So I want to visually show you what's going on here. So the x value is 25 and the y value is 17.02. Okay, and now you're going to see where this is where this point is being plotted here. Okay, so here's 25. I'm going to go ahead and now I'm going to go ahead and copy that so you can see what this graph looks like. Okay, so in this question here, you're not required to do this. I just want to make sure that you see this visually. So here is our point, and this is the predicted value. Okay, and again, our equation for this line here represents y, which is equal to 0.2059x plus 11.8714. Okay, now they want us to be able to compute the residual based on the observed head circumference of the 25-inch tall child in the table. Is the head circumference of this child above average or below average? Okay, so what do we need to do? Well, we need to look at the table now. So we're going to go back, okay, and then take a look at this table. So here is our table, okay, and then what I want to do is I'm going to go ahead and I want to copy this so that we have this table available for you to be able to see. So let me go ahead and copy this. Okay, so the observed value is what we have in the table. So we need to find out where is x equal to 25. Okay, so if we take a look at where x is equal to 25, we're going to see that it's right there. Okay, and now what is the y value? Well, the y value is 16.9. So therefore, the observed y value we have is 25 and then 16.9. Okay, now what was if this is the observed y value, then we need to come back up here and take a look at what the predicted one was. Well, if you notice here, when it was 25, we got a predicted value of 17.02. And this represents the predicted value, or the predicted y value. Okay, so just so I can visually show you what's going on here, I'm going to put this second ordered pair into our graph here. So our second ordered pair was 25, comma, and again, the observed value is 16.9. So I'm going to put that in there at 16.9. Okay, and now let's take a closer look and see what that point looks like. Okay, so there is 25, 16.9, and then there is our other value. So I'm going to go ahead and copy this so you can see what's happening. Okay. All right, so in this graph, you will observe or see that this point, the observed value, is below the line. Okay, and the residual is going to be the difference. Okay, so what is the residual? Well, in order to find the residual, we take the observed y value, and then we subtract the predicted y value. So we're going to take 16.9 and then we're going to subtract the 17.02. Okay, so if we take 16.9 and subtract 17.02, it's going to give us negative 0.12. So that is the residual here, and it would be negative because this point is below the line. Okay, it says to round it to 2 decimal places, so we're just going to leave it at negative 0.12. So let's go ahead and put our answer in here. So we have negative 0.12. Okay, now what we want to do is we want to be able to draw the least squares regression line on the scatter diagram of the data and then label the residual part in part from part C. So let's go ahead and do that. So here we're going to draw the least squares regression line on the scatter diagram of the data and then label the residual from part C. So recall that this was our equation, right? This is what we got from our linear regression line. Okay, and so this linear regression line, again, this represents the slope. So this is going to represent our slope, and then in our stat crunch, this slope is going to be listed as C1, and then this is the y-intercept, which is going to be C0. Okay, so let's go ahead and open up this data into StatCrunch, which we already have. So here's our data in StatCrunch. And so what we're going to do is we're going to go ahead and first graph the scatter plot. So I'm going to go to scatter plot. I'm going to make sure that the x variable is the height. Make sure the y variable is the head circumference. And then we want to overlay the polynomial order. So what we're going to do is we're going to select option 1 because it's the first degree. And then we're going to come in here and then we're going to select the following options. So remember, as I stated in the previous here, we can see that C0 is 11.8714 and C1 is 0.2059. And we're going to plug that into our StatCrunch. So 11.8714 and the slope is 0.2059. Let's just make sure that we're good on that. Okay, and now we're going to go ahead and make sure that we have our points, and we want to make sure that we have our horizontal lines and our vertical lines. And now we're going to select compute. Okay, so now let's go ahead and take a look at this graph. So I'm going to go ahead and copy this graph. So here is our graph. Okay, so what we want to do is we're going to identify the residual. But in order to do that, okay, let's take a look at the points we've identified. Well, the first point we identified was the predicted value, which is 25 and 17.02. So the predicted value, which is right on that point there, was the predicted value. And that's the predicted y. And that was the ordered pair 25, 17.02. Okay, and then now we have the observed y, and that was the observed from the table. And that point was, or is in this case, $25, and then it was 16.9. Okay, and so recall, what do we find for the residual? Well, the residual was right here, which is negative 0.12. So that means that this distance from here to here was the residual. Okay, and again, we found that to be negative 0.12. And again, any point that's below the line is going to have a negative residual. Any point that's above this line is going to be a positive residual. Now, let's go ahead and decide which one this is. Okay, so if we take a look at this first graph, okay, we want to make sure that this matches. So let's see if it matches our graph here. So let me go ahead and just kind of minimize this a little bit so we can match this graph. So, okay, here we have this point here. Now recall that this is 25 and then 2. And does this look like it could be the residual here? It's possible. Okay, because this is 25. And that could be 16.9. That is 16.9. Okay, let's take a look at here. 25. And that's 16.9. And there's the residual. Again, let's compare that with our graph here. So here's this point. There's that point above there. There's this point. And again, those 2 points are there. And then you can see that this point is on a line, so therefore it can't be that one. Okay, let's take a look at this graph here. Okay, so here's a point here. There's the residual. There's our 2 points here. There's those 2 points. That one, that one, that one, and that one. Those all match. So it looks like it's going to be C. So let's check our answer. And there is our result. Okay, now it says, is the head circumference of this child above average or below average? Well, because the residual is below the line, right, therefore, we're going to say that this is below average. Okay, and it says, notice that 2 children are 26.75 inches tall. One has a head circumference of 17.3 inches. The other has a head circumference of 17.5 inches. Well, how can this be? Well, the reason is that if there's 2 children that are 26.75 inches tall, their head circumference is going to vary. So one can have 17.3 head circumference, another one can have 17.5. Therefore, the answer is going to be A. And that concludes this question.